Very good morning, students. For this lecturing video session, I am going to give an introduction about perspective projection. This is the second chapter of Unit 5. In the first chapter, I have explained in a detailed manner about isometric projection. Right. Here, I am going to talk about perspective projection. What do you mean by perspective projection? Perspective projection or perspective view is to draw the three-dimensional picture of an object as it appears to the human eye. In other words, perspective projection is a graphic representation of an object on a single plane called picture plane, right, as it appears to the observer. Here the object is placed behind the picture plane and the observer is stationed in front of the picture plane. Therefore, the visual rays from the eye of the observer to the object are cut by the picture plane. That is, the rays which pierce the picture plane and form an object on it. This image is the perspective view of the object. Here, in nutshell, I would say that perspective means a picture taken by a camera. By using a camera is a real perspective. That means whatever appears to the observer, that is the perspective view. The arrangement of the eye, picture plane and the object is the same in case of the third angle projection. See, for all the other chapters, that is so plane surfaces, then solids and section of solids, then development of surfaces, isometric projection, we have drawn the drawing based on the first angle projection. That means the front view, this is XY line, right? The front view is drawn above the XY line. So here we used to draw the front view and in HP we used to draw the top view. This is as far as the first angle projection. This is as far as the first angle projection. See, for the perspective projection, here it is the other word. That means it follows it's similar to the third angle projection. See, as far as third angle projection is concerned, here the top view will be here. That is, the top view will be above the front view. Here the VP and here the HP. Got it? So, the front view in first angle projection we used to draw above the top view. As far as the third angle projection is concerned, the top view is above front view. So, remember it. Let me just cite some examples of this perspective view. So, let me just draw rail or the railway track. Railway track. Right. This is rails of a railway track. Assume a person stands in the middle of the track. The feeling of apparent convergence of receding of rails of a railway track is the case of perspective view. Here, look at it. It converges at certain distance. So this is the real perspective view as it captures by the human eye. So let me just cite some other example. If a person stands in the middle of the road, that means the long straight road, right, and looks at the trees on the both sides of the road, and it will appear the line of the trees converge to a point at very long distance. The view is experienced by the person is the perspective view of the highway. So let me just cite one more example. If a person stands at one end of the corridor of a long building, the lines of the pillar on both sides of the corridor will appear to be converging. So what it means? That means whatever appears to the human eye or the observer is the perspective view. Got it? So applications, when it comes to application, where it is used. See, as the photographic representation, it is extensively used by the architects to show the proposal of to show the appearance of the proposed buildings, and by the drafters for illustration of heavy machines or equipments, and by the artists for producing advertisement drawings. So these were the perspective projection or perspective views are used, right? So let me just get into the terminology. That means the perspective projection terminology. Here we have the perspective elements, which is picture plane, horizontal plane, here this observer, then central plane, CV is nothing but the center of vision, ground plane, HL is nothing but horizontal line or horizontal line, GL, which is nothing but the ground line, SP is nothing but the station point, which is nothing but the observer's eye. Got it? So VR is nothing but the visual ray. Here this is the object. When the observer look at the object, the image which will be projected on PP is the perspective view. Let me just explain in detail about each the elements of the perspective. Let me just start with the ground plane, GP. In short, it called as GP. GP is nothing but ground plane. It is a ground plane is a horizontal plane representing the ground on which the object is assumed to be placed. So as far as ground plane is concerned, the object will be placed on the ground plane always, right? So then let me just move to picture plane. In short, it is called PP. It is the vertical transparent plane on which the perspective projection is, the perspective view is projected. Here the object will be placed behind the PP. Look at here, this is the PP, this is the picture plane. Behind the PP the object is placed. The observer is stationed in front of the PP, picture plane. Object is placed behind the picture plane. This is the picture plane, right? And the observer is stationed in front of the picture plane. This is the for as far as the projection of perspective projection is concerned, this is the one which we follow. Got it? Here the top view, not top view, there is a front view of the projection of the elements and of the objects are projected on the PP. Here the position of PP relative to the object determines the size of the perspective projection. Suppose when we just place the object in PP, its perspective view will be in true size. Suppose the object is placed just in front of the PP. PP is nothing but picture plane. Then its perspective view is of enlarged size, right? Suppose the object, when the object is placed behind the PP, that is picture plane, it is in the perspective view is in reduced shape. So these are the three possibilities of the perspective views. First one, the object is placed in PP, then the perspective view will be in true size. When the object is placed in front of the PP, then its perspective view is of enlarged size, right? And if the object is placed behind the PP, that is picture plane, the perspective view is in reduced shape, right? So I taught you the definition of ground plane and picture plane. Let me just move to the horizon plane. It can be called horizon plane or horizontal plane. It is an imaginary horizontal plane. So it is an imaginary, this is the horizontal plane. It is an imaginary horizontal plane, right? At the level of the observer's eye. Look at here. The observer eye, that is station point. The observer's eye level is called station point. So the definition of horizontal plane or horizon plane is nothing but it is an imaginary horizontal plane at the level of the observer's eye, and this is parallel to the ground plane. This horizontal plane is parallel to the ground plane, right? Let me just move to the station point, that is, in other words, the eye level of the observer. Station point is the position of the observer's eye. Look at here. The observer eye is positioned in the station point. Its position is fixed at any convenient distance, either from PP or to the object. Got it? That is, the position is fixed at any convenient distance, either from PP or from the object. The shape and the visible edges of the perspective projection depends upon the distance of the station point, right? So let me just move to the GL. GL is nothing but the ground line. It is the intersection of, look at here, this is the GL, this is the intersection of ground plane and the PP, picture plane. The line of intersection of PP and GP is GL. That is, GL is nothing but ground line. Then let me move to HL, which is nothing but horizontal line or horizon line. Here, this is the line of intersection of horizontal plane and PP. This is the line. This line intersects the horizontal plane and the PP, picture plane. This horizontal line is parallel to GL, ground line. Clear? Light. So SP I have explained, GL I have explained, HP I have explained. Let me just move to the CV, center of vision. It is the point at which the center of vision pierces the picture plane. Look at here. This is the center of the axis of the vision which pierces. Pierce means it passes through the picture plane. Right. So definition is nothing but it is a point at which the axis of the vision pierces the PP. That is, PP is nothing but picture plane. Right. Anything else which I have missed? No. Center plane. Yeah, center plane. CP. Center plane is the imaginary vertical plane perpendicular to both GP, ground plane, and PP, picture plane. Look at here. This is the CP. This is the CP which is perpendicular to PP as well as GP. That passes through the station point. That passes through the station point. So the definition is, it is an imaginary vertical plane perpendicular to both PP, picture plane, and GP, ground plane, that passes through the station point or the human eye. Right? Center plane is over. Now visual ray. visual ray. VR stands for visual rays. So visual rays are the imaginary lines drawn to join the, look at here, visual rays are the imaginary lines which are drawn to the corners of the object, to the station point, which pierce the PP, picture plane. These imaginary lines are marked on the top view and projected to the front view to get the perspective view of the object. So let me just repeat. Visual rays are imaginary lines drawn to join the corners of the object to the station point, which pierce the picture plane. These imaginary lines are marked on the top view and projected to the front view to get the perspective view of the object. So now this particular terminology, that's a perspective projection terminology, is in 3D. How to convert that into 2D? Because 3D is very difficult to draw. Though perspective projection is to represent the 3D picture, but in order to draw for the students, that needs to be converted into 2D, right? So just observe it carefully. Look at here, let me just take this perspective, that is the picture plane. In orthographic projection, that is the first unit, orthographic projection, we used to draw the orthographic views, that is front view, top view, side views from the isometric projection. Assume this is isometric projection. Now I need to keep the picture plane which should be perpendicular to me. So in that case, I will just rotate the object in this direction, right? If I do so, the PP will be here. This is picture plane, which would be, this line would be like this, right? See, as I said, the object would be placed behind the picture plane and the observer will be stationed in front of the object. Suppose assume this is a square prism. This is a square prism. The top face and the bottom face of square shape, these are rectangular faces. As I mentioned, the object would be always assumed to be placed on the ground plane in this manner. Where could you see the true shape? When you just look at from the top only, you could see the true shape, right? So true shape will be obtained here. True shape will be obtained here, right? Either it would be in the PP or behind PP. Now the object is placed in this manner, that means it is in the picture plane. Suppose the object is something like this, that means the object is behind, some distance behind PP. Suppose the object is something like this, the square is something like this, that is some distance in front of the PP. So these three positions are possible for perspective projection. Now what I am going to do is, I am just keeping the object just behind the PP, just behind the PP. So some distance away from the, that is behind the PP. So the perspective projection follows, this is similar to the third angle projection. So in third angle projection, top view will come in the top and the front view will be below. That is, top view will be above the front view. Whereas in the orthographic projection, that is first angle projection, we used to specify the top view below and the front view on the top. It is other way around. Top view will be here and front view will be in the below. I'll just come to that. So now PP is position, right? Now I need to position the station point, for which I need to know this one, center plane. Center plane, since look at here, the object is in the right side. So therefore, the center plane would be on the right hand side. Look at here. Since the object is tilted in this manner, so in the right half the object is positioned. So therefore, the center plane is some distance away from this is CP, away from some distance away from the object. This is some distance behind the PP. So if I take this as Y, this as X, some distance behind the PP the object is placed, and then the center plane is some distance from the one of the side of the prism, square prism. When you just look at here, the station point would be somewhere here, station point. When you just look at from the top, you could see the station point would be somewhere here. Right. Next, this is top view is over. Now I need to concentrate on the front view. The front view is nothing but looking perpendicular to this object, looking from here. Right. So for which the ground plane is here. This is GP. Right. And the HL, horizontal line, would be somewhere here. HP or HL, whatever. Horizontal plane or horizontal line is somewhere here. Right, at some distance. At some distance. See, look at here. This point and the horizontal point is the same. So therefore, let me just take this as SP dash, that is station point 1 for the front view. Right. So in order to get the front view, let me just project it. This would be at some height, right? This would be some height. This is the front view. Right. So this is some distance in front of the PP, and this station point is some distance above the ground plane. This station point is some distance above the ground. So let me just take this as Y1 and this as Y2. Here, since I have mentioned Y for the vertical thing, let me just name this as Y1 and this as Y2. So the station point is some distance in front of the PP for this one, for the top view, and for the front view, some distance from the ground plane. This station point is some distance above the ground plane. Got it? So when the observer looks at the visual rays from each corners, Similarly, this station point, the visual rays from each corners of the object. What visual rays says, the imaginary lines are marked in the top view which pierces the picture plane, right, and projected to the front view. This is front view, this is top view. Now let me just project it. By doing so, it will intersect to get it. In order to get the perspective view. So since it is just for idea sake I have drawn here, the final view could be something like this. The final view could be something like this. So that procedure I just explained in detailed manner in a separate video. So this could be the perspective view of the square prism. It would be similar to that. So in the next video probably I'll just explain in detail about the procedure how to get the perspective view for the square prism. So this is the fundamental of or the basics of the perspective projection or perspective view. Hope you have all understood this concept. Thank you.